Earlier in the week, you guys learned about limiting factors, and limiting factors cause change. Those limiting factors that we talked about were like climate change and natural hazards, things like that. But I want to do a quick review, and it does go over your quiz as well. So this is going to be your review for your quiz as well as just a wrap up to make sure you guys understand it. We'll also have to do some graph learning as well, looking at graphs and understanding and interpreting the data from it. So how does limiting factors cause change? Well, the change that is caused is from things such as wildfires, decrease or increase in sunlight, temperature change, soil, water, oxygen, food, disease, competition, and predators. The first thing you have to remember about limiting factors is that they are abiotic and they're biotic. So you have living things that change population and you have non-living things that can change a population. Typically, this change is not for the good. So limiting factors limit the amount of growth that an environment or ecosystem can have. So some examples of some limiting factors is sunlight in the rainforest, where growth is limited to all plants on the forest floor unless more light becomes available. So the plants on the forest floor are typically very small because they do not get a lot of sunlight. Another limiting factor is in the 1800s, a disease called potato blight destroyed much of the potato crop in Ireland. You guys may remember this from history. Since many Irish people depended on potatoes as their staple food, so that's their main food source, mass starvation and immigration resulted. So people left Ireland or they died. This caused Ireland's population to dramatically decrease. It went down. The lack of food was the limiting factor, and it caused the population to decrease. And these limiting factors, when we look at these, we're mostly looking at decrease. So a current example of a limiting factor is the coronavirus in humans. As if a human survives it, they develop an immunity to the virus, to that particular strain. If they do not survive it, then it will decrease the population. So obviously there have been thousands of people who have not survived this virus, and it has caused a decrease in the population. So now we're going to move into our quiz review. So looking at this picture, we see some deer crossing a little creek here. There's some pheasants over here, and you can imagine there's probably lots of other animals here. If the rainfall in this area is less than expected, what is the most likely result on the ecosystem? So if the rainfall decreases, what do you think is going to happen to the water in the creek? It's going to most likely go away. And if that water dries up through here, the deer, these pheasants, and any other little creatures living in this forest will not have a water source. So when you are taking your quiz, make sure you focus on the water for this one. So the water is going to be your limiting factor in this ecosystem. And a pine forest has enough food to support 1,000 woodpeckers. Which factor could limit the growth of woodpecker population? So woodpeckers actually build their nests in dead and dying trees. And as you can see, this woodpecker is in the process of building a nest, and typically it's the males that build the nest, and then the female has to give approval. So if the pine forest is thriving and there's plenty of food for the woodpeckers, then there's not going to be a lot of dead or dying trees there for the woodpeckers to have nests. So this one is going to be a situation where shelter is going to be the limiting factor, and a shelter for a woodpecker would be a nesting space. All right, so here we have a herd of deer, and it says the deer population of the Grand Canyon National Preserve increased from 4,000 in the year 1905 to 65,000 in 1920. So that's an increase of 61,000 over the course of 15 years. The increase was due to a ban on hunting. So that means they didn't have anything there really to hunt them down and kill them. So in the Grand Canyon, obviously we don't have lions and tigers hunting these guys down like in Africa. And low number of natural predators. So again, we don't have the lions and the tigers coming to kill them and eat them. How did the increase in deer population most likely affect the ecosystem? Well, what do deer eat? Deer eat grass and shrubs, things like that. So what happens is that low-lying vegetation, the plants that are near the ground, get stripped away. And when it gets stripped away, it looks more like this picture here on the right side, where there's nothing there to hold the soil in place. The root systems of the grass and bushes hold the soil in place. So if the roots aren't there because the deer have pulled up the grass to eat it, then what's going to result is soil erosion. The soil is going to just wash away, as you can see has happened here in these gullies. So these gullies are basically where rain comes down and the soil just washes away. You don't have this nice flat land anymore. So low vegetation resulted in greater soil erosion. The soil is being washed away. All right. Horseshoe crabs are the primary food source for many migratory shorebirds. The graph compares the number of migratory shorebirds with the availability of horseshoe crabs in the Delaware Bay. Between which years did the population of migratory birds increase due to an abundance of food? So let's look at this. The bar graphs are the food because it says horseshoe crabs' eggs are the primary food source. So these bars, these gray bars up and down, are the food source. This is the birds. Okay, so what we're looking for, between which years did the population of migratory shorebirds increase due to an abundance in food? So as we're looking here, we need to see where the food increased and population increased. So if we're looking here, this is a decrease, but the food increased. Slight increase, but the food increased. Slight again, increase, a little bit of an increase here. Now this, we had our food decrease, and then all of a sudden our food source shoots up right here, and that's when our birds start to increase as well. Our population increased and our food increased. It got nice and steady right through here. So for this one, this increase that it's specifically talking about is right here between 1996 and 1998. The other years that are offered is 1988 to 1990. Well, we saw a decrease here. This is going down. The next is 1990 to 1992. Well, this stayed pretty steady. Right here, it's not really an increase. The next one is 1998 to 2000, another constant, steady right here. So this is constant, this is constant. This one is a decrease. The only one where we have increase is 1996 to 1998. A type of songbird feeds mainly on berries of a plant that stops growing in drought conditions. Now, drought conditions is when we have a lot of dry weather. We don't get the rainfall that we typically have. The graph shows the average annual rainfall in the forest for 16 years. So 1990 to 2006 is 16 years. This side says average annual rainfall. So we see it go up, goes down, up, down, up, down, up, down, up, down. So it looks like it's a pretty typical graph, predictable. It's very predictable. In which year did the songbird population most likely decline due to lack of food? So when we're looking for declines, we're going to look, here's a decline from 1992 to 1993, that would be a decline. 1996 to 97 is a decline. 1998 to 1999 is a decline. And then from 2001 to 2004 is a decline. And then again from 2005 to 2006. Now, the options are 1995, so we're going to go here to 1995 and go up. Well, that's not a decline, so it's inclining there. It's going up. 1999 is another option. We had this slight decline here, and then it's slightly inclined. 2001, well, this one went way up. So right here at 2001, this is really high compared to here. It went up. Here, this one went down. Here at 1995, this one is higher than before. So it went up to 95. It went down to 99. It went up to 2001. And it went up to 2005. So the only one that has a down would be 1999 for this one. All right. The graph shows the population of wolves and hare in a grassland. Now we know that hares are rabbits. They're a type of rabbit. Wolves eat them. And where were habitats, wolf and hare most likely destroyed by fire? Well, what we have to look for here is if their habitat's destroyed, then they're both going to go away. If you have more hares, then you're going to have more wolves. If you have less hares, then you're going to have less wolves because that's what they eat. So we need a decrease for both. So as we're trucking along here, we're going up, 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 up. And then right here we have a slight decrease, but you don't have a decrease in hares. So we need to see where they both decrease. So here the hares are decreasing and then the wolves are decreasing. And that happened in 2005. That's when we had a decrease for both beginning. So that fire most likely happened in 2005. All right. A biologist is studying the population of song sparrows in a region. The graph shows the number of song sparrows in the region from 1975 to 2000. Okay, so over the course of 25 years. The winters in 1980, so right here, were particularly, in 1989, right here, so these two, were particularly severe. Which factor most likely explains the decline in the song sparrow population during these 2 years? Okay, well, what do sparrows eat? They most likely eat bugs and seeds. Well, if it's extremely cold, then your temperatures are going to cause the bugs to not be around and the seeds to not be around for them to eat. So if the winters are particularly severe, that means that their food source is going to go down. So the limiting factor here is going to be food. All right. Can some limiting factors be beneficial? If we have a wildfire that destroyed 50% of the vegetation of a pine forest after 1 year, the burnt areas had more herbaceous plant growth than unaffected areas. So basically that's saying that more plants grew during that time. After a fire, what typically happens is nutrients are reintroduced to the soil because nitrogen, when all of this stuff, all of the trees and the plants and things like that burn up, nitrogen from that is introduced into the soil. Nitrogen is needed for a lot of plants to grow. If you guys remember me talking about the memorial gardens and we may need to introduce nitrogen into the soil out there, plants require it for growth. Plants absolutely need nitrogen. And the fires do help put nitrogen and other minerals back into the soil. Something else it does is it removes all the dead and dying trees. When all of those dead and dying trees are gone, it starts the life cycles of some trees over. So baby trees can start to grow where these dead and dying trees were. And you get to have a lot more plant life because of that. So that's your last 2 questions on your quiz. It is 10 questions. So if you need to go back and take notes, you can. So now you can go to Mastery Connect and take the limiting factors quiz. You can use your notes, anything you've written down from this video. You can pop this video up in another screen and go back and forth if you need to. But here are your codes. 80 is considered mastery. 70 is considered near mastery. Hopefully with this presentation and your PowerPoints from earlier in the week, you guys should be able to pass this without a problem. So again, here are your codes, and you can go to Mastery Connect and take that at any time. These codes are good for 7 days from Wednesday. So if you need more time than that, please let me know so I can reset it for you. But I'm hoping that you guys have this done on Friday or Monday.